So hello everyone. Today is day 6 of DSA preparation. Great. So the problems I solved today. The first one is size of the largest binary search tree in a binary tree. Second one was building a min heap or max heap. And third is this binary tree a heap or not? Then merging two max heaps, finding max heap. Great. Then kth smallest without using any build sort function. And then minimum cost of the ropes. Great. Well, let's walk through the project problems. Okay, I will just keep it here. I'll keep this in at last. Okay, let's start with the easier ones. Okay, so this one basically building min heap or max heap. Basically, we use the heapify function. It's very common, very famous. So basically, simply I just defined the heapify function and then I solved it. And the use of heapify and sort heap sort. So these two are very common when I solved like heap problems. Second, if is this binary tree a heap or not. Second, we have to decide two things on completeness and max heap. So it was very simple. I basically did an kind of in order traversal, मतलब level wise traversal. So defined a queue, keep on adding the values, and then I found that okay, here like here there is no values, like after 3 you can find there is no left or right, so from now on we can't add any more nodes. So like I kept a flag a variable, like flag variable. The moment I found that front node left is null or right is null, I kept a flag false. After that, if you are trying to add any value, mm, no, if flag is false. After that, if you are trying to add any value, it is not a complete. Well, I just try to combine both completeness and maxing together. So it was not just, you can say it a bit easy. I just have to think the logic. The great, this one was merging to binary maxi. So I just simply, it is very simple. We got have two vectors. I just appended the second vector to the first one. So I got a big one A vector. So in a vector, there is simply an array, and you want to get a max heap. No, there is an array, you want to get a max heap. So simply use define heapify function. We define heapify where there is heap problems. Just heapify and heap sort. Heap sort, I don't know, and we'll be using more. Great. So this is also kind of sorting problem, but we not had to use the sort function. Since I was working on heap problems, so I basically used heap sort. So here also heapify and just a bit in a heap sort. There's a just little bit more work. Without knowing these things will be a bit difficult. Great. This problem is minimum cost of loops. So I couldn't solve it when I tried to do myself. So here we use priority queue. And the rest of the concept was easy. Just we had to take care of that each time we were taking the smallest two numbers from the array list, whatever you're saying, and we proceeded from there. We defined priority queue. We pushed the entire values of the array into the priority queue, and then we got top two smallest and greater int. We kept basically smallest the priority, so we get two smallest number, we get a sum, and then push out the sum, and we also keep our problem. So the thing to do is we use priority queue. I'm still not confident in priority queue. Maybe when I will work in future, I will try to focus on that. This was a bit interesting and difficult. The size of the largest binary search tree in a binary tree. So here, actually, I looked for the solution only. So there he defined lover basically. He defined a class. Well, basically, when we in binary tree in base problem, we were defining a kind of pair or dictionary at each node. So this similar to that, but we for each node we kept max, min, is BST and size. So there were also kind of recursive function, and let's forget about that. Let's just check how things are working. base case recursion. Okay, so this basically we define current sizes, left tree size, right tree size plus one, and we have to check left is BST, right is BST, and the root data is greater than the max of the left, and root data is less than the right of the min, and then the current node BST, it is BST true, and then we saved current min and max. This is, you know, min from root data and left's min, current root min max. And since it was a BST, we have to update the answer, keeping the answer and the kind of size. Great. Let's also like this. Yeah, it was very difficult to solve it if you were trying it the first time. I'm trying to learn it. Great. That's all for today. Then bye bye.